OpenWhisk release process is we are now able to release all the source code packages at this moment. As you can see, all the 12 OpenWhisk repositories listed over here, and their corresponding hash values listing downstairs. We already make sure that this hash value, the version of the hash value contains a valid license file and a notice inside that repo. And currently we're working on to add, trying to add the license headers if missing to each of our OpenWhisk repositories. Based on what we have found out, we trying to add the headers, either full headers or a half headers to each valid files, and except the action itself. For example, as we have a lot of default actions files defined in OpenWhisk catalog, so we will not add the headers into the real actions. Because that will bring more loads into our system, into our OpenWhisk system. So we'll definitely have a bad influence on our performance. And some configuration files, like property files, or this JSON configuration file like this guy, we will not add the license header either. So, and some Gradle files like this guy. Oh, it's not over here. For example, in this repo. Okay. For example, this guy, Gradle or Gradle.bat, which are actually generated by the Gradle commands, and we will not add the license header either. So, except those files, we're trying to add either full headers or the half header to all the other source code, which are quite valid in each of our OpenWhisk repositories. And I can show our define our staging. Okay, it should be over here. Oh yeah. Yeah. As you can see, this are the source code packages for 12 OpenWhisk repositories listed over here in this staging directories with signature, with MD5, with SHA 512 as the checksums, and they're all valid at this time. User guys can download them, verify those checksums with this public key I upload over here. Yeah, this is the current status regarding the source code. Regarding the source code artifacts, which are uploaded in our staging directories. Next, to move on further, release in an incremental way, we either can follow this tutorial over here. We can find in this OpenWhisk release repo is down over here in the doc, on the docs in the tutorial markdown files. We can go through 1, 2, 3, all the 10 or 11 steps in order to push a kind of artifact into staging URLs. And here, for example, publish, like making this release artifacts, we're already done the step for all the source code artifacts. And next we'll move on to binaries artifacts and image artifacts. Or you can follow here the automated mode, a release as we're developing the configuration file, and let the Travis guy to kick off a job and sign the artifact and push the artifact into staging directory for us. So this kind of two modes. I think everyone can try it out if you're interested. You can either try locally with the manual mode or the automated mode by submitting PRs to this repo. Let the traffic do the rest of the jobs. And we do have a question at this moment. I just sent out a note to our dev, into our dev mail list, which is a problem, which is a question regarding the tentacles. So we were about to use. The problem we have now is that we try the commands by providing the staging URL as listed over here and try to generate the report for the license and the notice. And here is the result. The result is that we got a empty files with empty content, empty license, empty notice. And we know that there is a license, there is a notice inside that jar, inside the artifacts, but we just get everything empty. But we, at least I have no idea at this moment why it look like this. I don't know what was going on. I'm not sure anyone who has similar experience or who knows this technical better than we do can help us through this kind of weird issues.
Yeah, we should, I saw your email, we should forward that email. You can forward that email and CC the dev to the general, to the mailing list in the incubator, general incubator.
Yeah,
they should be invited there already doing it.
We looked at the support page for creator and these things, and it looks like no one's fixed any bugs there for 2 years or so.
Yeah, this is the kind of issue we have with this technical tools. But as a kind of let's say, well, to compensate this kind of problem, I have submit a PR with the check. Let me see. Yeah, I submitted this commit. I just verify, change. I can verify the existence of notice and license with the bash script. Yeah, so this is currently how I verify the license and notice files under each repo.
Yeah, we're trying to be very diligent at documenting everything we're doing and where we have problems. So.
Yeah, so I would say try to find help on tentacles. If it doesn't work, just let's do it ourselves.
Yeah. That's what I said. As long as we document our processes and show that we tried these different tools, then we're good.
Yeah. Issue. Other than that, what's holding, for example, me of driving like a first release and starting that, let's say, tomorrow. Or maybe next week.
So we have also the problem with the rat tool. The rat tool, we talked. Daisy's working on that right now, so we still have to add
license.
More files than we wanted to. So initially we negotiated. We added license headers to all the source files, and we decided as a group which directories to exclude and which files to exclude. But we found that other projects are including more files like Markdown and other files. But so we went through a list. I think Daisy's going to post it to the dev list and also create a document, a Markdown document in the release repo, indicating which types of files need headers and which ones don't. The problem is the old rat tool doesn't support the mini header. And so that's a showstopper for us. We can't add headers to function files, these huge headers. That's something that we totally agreed to long ago.
Yeah. Write our own.
Well, we have our own. We have our own. We have scan code, so we just have to document.
We have our utility.
Yeah, remember that these tools are for helping the projects meet the policy, not required, right? So meet the policy. That's what we're doing. Okay.
We're trying to make it as compliant as possible.
Okay. So a couple of weeks, we're making progress on a few things. So super happy from this progress versus, I say, 2 months ago, right?
Yeah, thanks, Vincent, and thanks, Steve.
No problem.
Thank you. It's really good progress. Okay. So if you don't have any further questions on the release process, I think that we could jump to the next topic that we have on our agenda, and that's the Go-based and that's Go runtime, which should be presented by Michel. Okay, you're here. Great. We can't hear you. At least I cannot.
You're muted. You're muted. I can unmute.
Can you mute him?
I can unmute. I unmuted. I tried to.
We cannot unmute you. We can hear you. Fortunately.
I'll try. Yeah, it's not letting me unmute him.
Michele, we can't hear you. Can you hear me?
Oh,
Yeah.
now we can. Yeah, great.
Can you see
You
my
might
screen?
We tried to introduce you last week too, so you might want to introduce yourself.
Okay.
That's a good idea.
So I am Michele Chabarra, and I work. I am a UK-based company, and that we focus on DevOps and serverless. And I am a great fan of OpenWhisk, and then I started to contribute. Actually, I was working since a long time, but I started to contribute 2 weeks ago with the Go actions. So now I explain the work I have done so far. And please confirm you can. Are you seeing my screen or my face or my screen? Are you seeing my screen now? Yeah. Okay. Go on. So I go with the slides. So let's discuss with the. Okay. So first is why. Actually, I worked on this because I'm using Go for serverless application on AWS Lambda. And most of our work is for Kubernetes. So I was looking for a good serverless Kubernetes solution. And I chose the OpenWhisk, of course. We know the reason that open source, the problem of serverless is the vendor lock-in, and OpenWhisk looks like a good solution for that. But mostly the reason because I started to participate is that App Wanted was there for Go actions, so I thought that was the project for me, and I started to work. First thing you would to know is why Go. I think there is only one word for Go, because it's fast. It's fast to learn, it's fast to develop in it, it's fast to execute, it's fast to deploy, and it's fast to debug. So the only language I really want to use in a serverless environment is actually Go, and because Go, the status support of Go in OpenWhisk was not really the best I was looking for, because currently Go support is based on Docker skeleton. And so it works, you take an executable, you upload it, then there's a Python proxy script that will receive a request, then it will start another executable, pass a parameter on it, collect the output and send back. I have seen something like this before, many years ago. Something called the CGI. That is not really the fastest way to work. It's not the most efficient way to create a web application and I think service applications. So I try to improve it, and I start to write in the mailing list what we could do. So the most obvious way is to replace the entire proxy with another proxy written in Go. But of course, it has issues. Actually, I implemented this, but the most important problem is you can easily break the whole runtime if you upload the executable that is not properly built. Then there's a problem that when you upload the the replacement executable for executing the actions, there is a condition where you have to shut down the socket, then start another one. So it's a sort of race condition that can be a problem. But the most important is that this approach is not reusable, because we could use the same approach for improving also Swift actions and in general the Docker skeleton. So the obvious way was to keep a fixed proxy and then run the actions like an executable that is running continuously, reading in input, writing in output, and producing log on standard error. Basically to act like a standard Unix utility. So this is the simple architecture. You will have an HTTP server. The HTTP server will receive post request. Then we'll feed those requests in the standard input to the action that will process them line by line, produce the output line by line standard output, produce the log standard error, and then everything is returned as a response. A simple one, actually. Nothing really complex, because many applications in Linux works this way. For example, plugins for GIMP, they are done this way. They start a sub-process and then feed input and output, but it's not the only one that works this way. So far I was able to implement the first thing as an exec replacement. So this, I already did the first implementation that was replacing, and I was actually keeping in a branch. I have not turned away. And then I extended the exec replacement, implementing in another branch that I call the pipe loop, that will do in the way I just described. Actually, I tried the pipe loop with a Go action, and also I tried the pipe loop also with a Swift one, a Swift executable. I had to hack a Swift executable to do that. And then I built a few Docker images to try this thing. The question is it fast? That's the point. So everything is actually was a bit hacked away to test the speed. The numbers are a bit surprising, because you can see in this picture that compared to the Docker skeleton, the pure Go server, so when I replace the executable with a new proxy entirely written in Go, I have 4 milliseconds for requests compared to 2 seconds for Docker skeleton. If I use the piped executable, on average, I have 5 milliseconds. So the piped exec is slightly slower, but not so slow that is not worth to use. So I think the piped executable would be the solution to go. Also, I compared the results also with a Swift executable. The Swift executable is slightly faster, but it still will take 1 second to execute, on average, to execute one request, compared, instead if I pipe it in a proxy done in Go, I get 4 milliseconds on average for request. So far we have an improvement of 500 times on Docker skeleton, 250 times on Swift, so I think it's worth the effort. So where am I? What to do yet? On short term, I have to complete the implementation, properly managing only the error conditions. The most important thing is to be sure that I do not get stuck when, for some reason, the child process misbehave. So then I have to run the test suite against the executable. Then I have to do a few changes to the command line to support the actions, create a client library to make it easy to write actions, and then hand over. On the medium term, we have to see how to use it for Swift action, Docker skeleton, and then there's a lot of things to do, but still on the plan. Let's do things short term. Okay. That's it, and okay, I stop sharing.
Yeah, this is great. This is great to have. Welcome to the OpenWhisk community. So very glad to. This is how open source supposed to be. Yeah.
Yeah, welcome.
Okay, thank you very much.
Just one quick question. So I have seen the numbers and they are really amazing. But which HTTP server have you used? Just a normal net HTTP packet, or you have used some other one?
No, I used the Go one.
Mm-hmm.
The Go includes an HTTP library that is native to Go, and then I use the HTTP Go library that is included as server.
Okay.
So that was the natural idea, because one reason for using Go for a serverless application is that you can build your entire serverless locally and then just publish it. For example, on AWS, you create your local executable and you run locally, and then you upload with serving HTTP. Then you upload there, and then your HTTP is replaced by the remote one that's actually a RPC infrastructure in AWS. With this thing, you can actually run your local one and then upload as this, more or less. But anyway, basically the Go HTTP server is a good replacement for the proxy. And also another thing is that the Go routines make very easy to create the forked, the child process that you feed input and output, because almost all the infrastructure is in there, is in place. It's much more complicated. I gave a look to the Python implementation. It's pretty much complex compared to the Go code. The Go code is very simple. So I would say that Go is designed to do those server things. So it's a good. I would say that it's easier to do that in Python, to be honest. For me, it was very fast to implement. So I think, yeah.
Okay, so my question was basically more like, have you compared some other HTTP servers which were written in Go with the one that you have used? Because I have seen some performance number of the Go-based server HTTP servers, and they are like really different. And there are ones which are extremely good at it. And if you have reached such a good number with a standard Go library, what I mean is that you could probably reach even more with a more advanced library.
To be honest, I don't know if there are others, because so far every example I have seen are referring to the standard library. Okay. And I don't know if anyone has written anyone else since the standard one is so good. Probably someone was so crazy to do that, but to be honest, I don't think so. But I will check just to be sure. No issues in doing that. It's very easy. It's just an handler, and yeah. So yeah, I can check if the other libraries.
Okay. No. I'm just not saying that you need to check it. I'm just wondering.
No, I'm curious now, to be honest. But almost everything in the Go world refers to the standard one. Mm-hmm. So it's like native out of the box Go as an HTTP server. So I use that normally, like a string library. Would you use a different string library for your Python code? Usually not. You take the one that's coming from. But anyway, I can check. No worries.
Later, we need to evaluate the dependencies. We bring more dependencies. Also, we're not really a web server that stays all the time and needs to support everything. It's just one /init /run, right? Get in, get out as quickly as possible.
Yes. No, but it's very fast. Also, is that zero dependencies or glibc. One thing that's very nice is that the runtime is only 10 megabytes. It includes everything because Go has no dependencies of the libc. So it's very small. You take the Alpine that is 5 megabytes. You put another 5 megabytes, you have 10 megabytes, everything. For Swift, I had to put all the dependencies for Swift, and the image was huge, 1 gigabyte. I think not everything is needed, but the the Swift dependencies as a dependencies of glibc and at least another 10 libraries. So it cannot be so small. For Swift, you need, I think, at least for probably 200 megabytes at the minimum, I think, if you trim down. But so far it's huge, because I used the Swift Ubuntu images for doing that. Anyway, okay.
Michelle,
Sorry.
Too much stuff?
first of all, benvenuto in your language, Michelle.
Grazie, in my language. Do you understand my English, or I have too much Italian accent?
It is perfect.
Okay, thank you. Thank you. Good lie.
So I had two questions actually. So the first question is if you think this approach would support streaming.
Yeah. To support streaming?
Yeah.
I think it's possible, but let me think. What I've seen that they support for HTTP2, that could be the best option for that, or you can do the chunked implementation. To be honest, I was looking if it's possible to use WebSocket, because it's the biggest missing thing, in my opinion. Also, Go has a good support for WebSocket, as far as you know, so it should work.
And you don't kill the child process. You keep the child process again, so every invocation uses that child process over and over.
What do you mean?
The user's code, when you execute the child process, it doesn't exit. You keep asking for every invocation run. You put standard input, standard output. That doesn't end.
When I start something is called a Go routine in Go. Yep. And then that will be simply waiting for a channel. When I write in the channel, it will feed the input to the child process. Then the child process will read the input, process it, write in the output, and that's it. So you can easily, if you have an HTTP server that can listen for continuous stream, like could be possible, or a WebSocket, for example. If you put a WebSocket server, that should work, no issues. So it should not be difficult, because as long as you have a library that can support WebSocket, you can feed it to the action exactly the same way. So I think it's it's possible and not difficult. I have not thought about, but I thought about the WebSocket support. Yeah.
Thanks. Okay. So right now, OpenWhisk doesn't support necessarily this streaming, but like if I was thinking at this, because if we redesign the action containers, maybe in the future we would want to support this. There is some conversations around supporting HTTP invocation. Yeah. Thank you.
Should work easily. It's better that I complete something, but I would be happy to work on trying the WebSocket streaming afterwards. So, yeah.
Okay, great. Thank you for the presentation. So I think that we could go to the next topic. So in the original plan, the next topic was Ganesh with the update on the Spring Cloud functions, but he unfortunately could not make it today. And we could go directly to another topic, which is Composer. And Olivier, if you are here, yes, I think you are. Okay. You could take it over.
Let me share my screen or my PowerPoint. Okay, so can you see the slides now? Can you see my slides now? Can you hear me?
Yes, we can.
Okay. Yes, so this is an update on two related topics. The first one is conductor actions, the second one is composer, so I'm monitoring from IBM. So conductor actions, the first topic is a new thing we've added to OpenWhisk. So this is a series of pull requests that have been merged and essentially impact the OpenWhisk controller. So you can look at there's a GitHub link about the main documentation here. So the idea here is to add to OpenWhisk the ability to run dynamic sequences of actions. So we already have action sequences in OpenWhisk, but they are about running a fixed series of actions that is decided before execution. And conductor actions make this more flexible by making it possible to decide the actions to run in a sequence as the sequence is running. So at every step, we can decide what to run next, again and again and again, and that gives us much more flexibility and makes it possible to implement much richer compositions of actions. So that's the first topic. I'll go through that. The second topic is Composer v2. So Composer, you can think of as a library, an open source library, a JavaScript library, to make it much easier to write conductor actions. As you'll see in a minute, writing conductor actions by hand is not really necessarily very nice, especially outside of the simplest cases. And so Composer is about that. No, Composer existed before conductor actions, so there are lots of new things in V2, but the main thing is V2 I want to talk about here is that it's now implemented using conductor actions. And again, you can find that on GitHub. So this is open source. So at this time, this is not an Apache project, but you can think of it as fitting into Apache. You can think of the conductor actions as one piece of conductor v1 that we took, and we bring to Apache OpenWhisk. We took from Composer v1 and we bring to Apache OpenWhisk. So here's the quick slide on conductor actions. Here you have a sample program, a sample action. So at the top of the slides, you have the code for the action, and at the bottom, you have how you use it. So let's start with the bottom. So the main point here is that conductor actions are just actions. So you create them like you create any action. You invoke them like you invoke any actions. You can do block and invoke. You can do web actions. All of these things are possible. The only difference here is that you have to specify an annotation with the -a conductor true in there if you use the Whisk CLI that tells the OpenWhisk, that tells the controller that this is a special conductor action and it should be taken care of using the special paths. So what you see at the top is the code. And essentially, this code here describes a program with 3 steps, which says in the first step of the program, we're going to invoke an action called triple. In the second step of the program, we're going to invoke an action called increment on the result of the first step, essentially. And in the third step, we're just going to return the results, right? And so you can see, here we're manually managing the state of the execution using this $step variable. And all of these are the things we can hide using Composer later in the presentation. And this is a very basic example because it really doesn't go beyond what you can do with sequences today, because essentially we're calling one action that is known at compile time and a second action that is known at compile time. But you can see easily how I could change this code to actually use, to actually dynamically decide what I want to run. So going into a bit more details about what's going on here, the conductor action essentially must return a dictionary, a JSON dictionary that is a triplet with 3 elements. Not all 3 of them needs to be there every time, but these are the 3 that you can have. The first one is the name of an action, or the path, the fully qualified name if you want to an action. The second one is a parameter dictionary, and the third one is a states dictionary. So what happens when you run a conductor action is that at the end of the invocation, the controller looks at these triplets. And then there are 2 possible cases. Either action is defined, is present in the triplet or not. If action is not, then essentially this is the end of the series of invocations, and we just return the params. On the other end, if actions is defined, is present in the triplets, then what the controller does is it goes and invoke actions, this action on the params that are specified, it gets a result from that. So it's a normal action invocation in the sense it goes to invoker, container, etc. And so we get the results. And then what happens at the end of this execution of this action, this dynamically decided action, is the conductor action gets reinvoked by the controller. And this time the parameters of the conductor action is a combination of the result of the action we invoked and the last element of the triplet, the state we specified last time. So if you look at the example we had before, just coming back quickly, you can see that essentially the state was used here to pass as a parameter to the next invocation of the conductor action, the step we've reached in the execution of the program. So again, you can look at the documentation offline, or we can discuss later if you want. So that's basically it. That's what happens in the controller. And what that means is when you invoke a conductor action, just like when you invoke a sequence, from one invocation you get a series of activation record, not just one. So there's one at the bottom that corresponds to the whole series that will have, in particular, the final results for the invocation. But there are a few more. So like a sequence, you have invocation of each action that is composed in the series, like you have the triple action that is invoked here, and the increment action also. But in addition to that, you also have what we call secondary invocation of the demo action, which essentially are all those invocations that decides what to do next and what to do next and what to do next. Right? So an execution always looks like that. You have execution of the conductor action, execution of the a composed action, execution of the conductor action, and so on and so forth. We alternate between the two. Need to keep track of time. Yes. So a few key points here. So the first one is a conductor action is an action with a conductor annotation. So in particular, in contrast with sequences, it's not a separate kind. It's not a new thing. You can use any language, any runtime to implement your conductor action. I talked about the activation record. Pretty much the same thing you have for sequences. So if you look at a final activation record for the conductor action, you'll find the duration, which is the sum of the duration of the steps, the list of the activation IDs for the steps, the results, etc. An important point is that there's a convention on what's the structure of the result of the conductor action should be. But on the other hand, there's no restrictions on the inputs of the conductor action or the final results of the conductor action. That means you can do anything with conductor actions. You're not restricted to not use parameters like dollars. Like in my example, I was using $step to encode the stage of my computation. I could have used anything else. It's entirely up to you. We specify action names in conductor actions. So this is the usual. You can just have the name, the package, the name, the namespace, etc. That should work. This was the one thing that was buggy initially, and we have more pull requests. We had more pull requests. Hopefully, this is all working as expected now. One difference between sequence actions and conductor actions is because it's dynamic, everything is dynamically assessed. So when you create a sequence in OpenWhisk, it might tell you that the component doesn't exist. That doesn't make sense for conductor actions. We look for components at runtime. We verify that you're entitled to run these components at runtime. And we also verify that you don't go beyond a certain limits on the number of steps at runtime. So conductor action might fail at runtime because you failed one of these tests. And this is implemented in the controller. I've said that already. Okay, so let's switch to Composer at this time. So Composer, as I said before, is a JavaScript library to program action compositions. And the new thing is that we compile essentially those action compositions to conductor actions. So here's the same example as before, using Composer rather than just conductor actions. So the code becomes, trivial here. I'm saying I'm doing a sequence using a triple and increment. And essentially what the Composer library is, takes this code and generates something that is semantically equivalent to the code that you've seen before. So that makes it much, much more practical and much more useful. And more importantly than that, it goes much beyond sequences. So you can do all kinds of things with Composer. You not only sequences, but also tests, loops, try-catch things. We have retry, where we can say, I'm trying this action 3 times, and if it succeeds within the 3 attempts, and this is good, otherwise for an error. We can invoke not just actions, but we can also include functions. So I don't really have time to go through that. Again, you have pointers to the documentation. I should point out that the documentation for V2 is not entirely written yet, but if you look at the V2 repository, it's some files have warnings about not being updated, and others are fine, and this is work in progress. Just to go just a bit deeper on this, we create these compositions. There are really 3 ways you can do that, starting from the piece of code I had before. Now we support 3 options. So in Composer with V1, you had to use the Cloud Function shell to deploy your compositions. Now you have 3 options. The first one is still to use the Cloud Function shell, and we still recommend to do that because there are lots of good things that comes from the shell. For instance, looking at the graph of your composition. Again, I don't really have time to discuss that today, but you can look at the shell documentation, the YouTube videos and stuff. Lots of great things there. But if you don't want to do that, don't want to depend on the shell, the Composer Node.js module now includes a shell script to do the deployment, by itself. So you can say compose demo.js -- deploy demo, and it would do exactly the same thing. And in fact, this shell script is just a small wrapper, around your composition code that generates something like the code at the bottom. So essentially, you can do what I'm trying to say here is essentially you can use Node if you want to do everything. So if you just want to use Node, then you have to manually instantiate the Composer module. You have to build your composition as I was doing before, and then you have to manually instantiate. Essentially, there are OpenWhisk JavaScript clients for OpenWhisk, which we've extended to now support compositions, and then you call deploy on that, you give a name to your composition, and you can do all of this through JavaScript with no other dependencies and no other module required. So there are many more new things in Composer V2, so I just want to mention one here. So one big change is coming to Composer V2 is that we changed the representation of compositions. So if you know anything about Composer, what we were doing before is you would write your code in JavaScript, and then we were generating essentially a finite state machine to implement the composition. Now we moved, but the finite state machine was really a runtime structure, not really great to look at or debug. And so what we're doing now is when we take the composition code written in JavaScript, what you generate out of it is a JSON representation that is pretty much of that. You have an example on the left, and that's pretty much something that looks very, very similar to what the composition was in the first place. So here we're saying this is a composition. This composition is an array, which means it's a sequence. It has 2 steps. These 2 steps are actions. And so the great benefits of that is it retains the structure of the code. It's completely language independent. So we could, you could have the same thing containing, coming from Python, for instance, if you wanted to. It's self-contained, meaning you can, in this format, normally define a composition, but I could add also the definition of the triple action if I wanted to. So I can define complete self-contained applications using this format, and it's a serialization deployment format, meaning the FSM is now just a runtime thing you don't care about. And actually what I was doing before, deploying a JavaScript composition, is essentially a syntactic shortcut for saying, please compile my JavaScript composition to this JSON format, and then please deploy my JSON format. And you can actually do that if you want. And this format is good for editing and other things. Okay, so there's a lot more to Composer V2 I don't want to go through because it's been 14 minutes. So here's actually a copy of the commit message, the main commit message for the main pull request for Composer V2. So I mentioned a few things already. So the main one is we're using Conductor actions, which resolve double billing as well, if you're familiar with that. The JSON format has evolved. We can now bundle together the composition and the components of the composition. We had a new construct. We tweaked a few existing constructs based on feedback. We have this new compose command that can do composition without requiring the shell, and a few other things. In particular, the fact that now we're deploying a single action And the action that we deploy is entirely self-contained, doesn't depend on packages or anything like that. It contains both the code for the scheduling of the composition and the details of the composition. And that's a much nicer thing to do. So to conclude, there are a few more things that are coming in the short term. I think talking about conductor actions, one limitation is that you cannot use sequence actions to be conductors. There is nothing fundamental about that. It was more of a tactical choice about not touching too much of the controller code at the same time. So there will be a PR so that sequence action can be conductor actions. Conductor actions and sequence actions both have notion of steps, and they count the steps to decide when you have too many steps and we should stop you. But today the counting is independent between these two kind of things, and I think that should probably be counted as once, and this is likely coming shortly. Composer v2, the main two things coming next are parallel constructs, so that you can do fork and join or map and reduce kind of compositions. We're going to reintroduce Redis, so I didn't talk much about that, but it's coming in the future. And so what I'd like to you to think about and help us decide what we want to do there is two main questions. The first one is, now we have conductor actions, and fundamentally they are more expressive than sequence actions. So it's a bit confusing for users to have, one mechanism and then one specialized mechanism. So what should we do about sequence actions? Should we get rid of them? Maybe not. Should we reorganize the way we talk about these things? So this is definitely an interesting question for the future, and we, love feedback about that or thoughts about that. The other big question I think coming up is that sequence-like conductor actions are implemented in the controller today in OpenWhisk. And I think as we're looking to, in particular, to moving on top of Kubernetes, this might need to change. And maybe the notion that we have a controller that orchestrates a series of invocations, maybe this needs to be split in some way. And again, that's an interesting architecture question that should be discussed at large. So that's it for what I have for today.
Thank you very much.
This looks awesome. I'm a big fan of the composer and the shell, and especially of the programming model. I do have, for some reason, a problem with Redis, trying to understand why, like, when this moves into the controller, what role will Redis have that the controller cannot fulfill?
So there are several limitations of what we can do with the controller. For instance, the amount of the size of messages that go back and forth between the controller and the invoker are 1 megabyte, right? So that means, and this message, when you use Composer, includes the state of the application, right? If you look at the conductor action, there was this $step, parameter, and it counts as part of the 1 megabyte. So if it's just a number, it's okay. If you're starting doing bigger things, in particular, if you're starting doing some kind of persistence, which we do in Composer, saving and restoring parameters so that we can use later, this amount of state can grow. And conceivably, it could grow beyond the 1 megabyte limit. So that's one place where having an external data store can help, is it, instead of passing around the large states, we would pass around a reference to the state and store the state elsewhere. That's one of the reasons. Another reason to use Redis is parallel constructs, because when you do fork and join, at some point we want to join parallel branches, and now we're done. And that means at the very least we need to keep track of a counter somewhere that says how many branches have completed, should I go on or not. And this is exactly the kind of things where I think eventually this will move inside the controller, because it's a small piece of state. It doesn't really make the controller too fat, I think. But just like we did with Composer v1, initially it's going to be external store, and then as we investigate, experiment, and agree, as a community that it's a good thing, it's probably going to move inside the controller. So this kind of, the last element I have on the slide here is that conductor actions today are limited to 50 steps, because we want to make sure we just like sequences. We want to throttle properly, we want to control the resources properly. But conceivably, we could do longer compositions by running 50 steps, storing the results in Redis, and then eventually resuming. Right. So that's the third reason to have an external data store.
I think that we are running out of time. Thank you very much for the presentations today. And I think that we already know who will be the next moderator, right? Then, am I correct? You have proactively volunteered to that.
Yep, I'm in.
Great, thank you. And I think we also, last time we have just, if you let me just use one more minute, last time we have missed, I think, the updates from the Adobe side, probably Dragos or Tyson, if you have any updates, just a couple of sentences from your side.
I don't have anything specific. I've been working a little bit lately on the Mesos Container Factory, trying to get that wrapped up with reviews with help from Marcus. So hopefully that'll be landed soon.
You guys have plans for your developer conference in a few weeks? That's what I've been curious about.
Dragos may be able to talk about that. You mean for the digital marketing summit?
Yeah, basically I would mention that we try to bring forth the programming model that Composer adds, and we're playing with some AI actions. So I expect to see some AI and Composer being the highlights of what we're going to do. There's more to share on this, but we're really working hard to make this production ready and fixing all the security things there. So yeah. And you'll see, maybe I'm trying to find time to work on a small pull request that adds what I spoke with Roderick, and I will be asking for your support to be able to merge that thing with the permissions X, which makes an action shareable but doesn't show the code. That's particularly important.
HDL, yeah.
Okay, thank you. If we don't have any other questions or comments, so let's close this call and see you in 2 weeks.
Hey, we need a moderator, Dean. We need a moderator.
But we do have a moderator, right? That's Dan.
Oh, Dan's volunteering. I'm sorry. Okay, didn't catch.
Yeah, he already volunteered.
Okay, thanks, Dan.
No problem. Thanks.
See you.
You got 2 weeks to buy a hat, Dan.